It's a calm September evening over the Arabian Gulf. Yet, the situation 20,000 feet above it is anything but peaceful. A Boeing 747 freighter has just taken off from Dubai, but a fire indication is prompting the flight crew to return to the airport. As the pilots complete the emergency checklists and prepare for an immediate diversion, the flight deck fills with thick smoke. Struggling to get oxygen through his mask, the captain hands control over to the first officer and leaves his seat to search for the portable oxygen bottle. He never returns. The first officer, left entirely on his own with a rapidly growing fire, needs to land immediately. But the smoke makes it impossible to control the aircraft, let alone land the Queen of the Skies. How did a small fire create chaos on board a cargo airliner? And what actions did the first officer, now flying solo, take to try and save it? This is the story of UPS Flight 6. On September 3, 2010, a UPS Boeing 747 parked at the cargo ramp in Dubai International Airport for a quick stop on its way to Cologne, Germany. Operating the regular route, the aircraft had begun its journey in Hong Kong earlier that day and was being loaded with additional cargo in Dubai. The flight crew had flown in a day earlier and was ready to begin their duty as the pilots of UPS Flight 6. Captain Douglas Lampy, the pilot in command on this flight, had been with the company since 1995. He had accumulated over 11,200 hours of flying time, including more than 4,000 hours in the Boeing 747 aircraft and 2,400 hours as a captain. An experienced pilot, he had flown for passenger airlines before joining UPS. Accompanying Captain Lampy was First Officer Matthew Bell, a U.S. Marine who had acquired a total of 5,500 flight hours. With prior experience at a regional passenger airline and a type rating for both the Boeing 757 and 767, he was new to the Boeing 747 with only 77 hours on type. First Officer Bell was the pilot flying on this leg, responsible for operating and controlling the aircraft. As the pilot monitoring, Captain Lampy was in charge of keeping a watch on the flight parameters and communicating with air traffic control. Lampy and Bell would be operating a 3-year-old Boeing 747-400. Unlike many freighters that begin their journey as passenger aircraft before being converted, this 747 was delivered straight to UPS as a cargo aircraft. Most of the aircraft's payload had already been loaded in Hong Kong, and the stop in Dubai was not going to take long. While the ground crew removed some cargo and loaded new containers onto the aircraft, the flight crew was busy preparing for the flight. Reviewing the aircraft's logbook, they discovered that one of the aircraft's 3 air conditioning packs, pack number 1, had malfunctioned on the previous flight and had to be reset. An aircraft mechanic in Dubai tried to troubleshoot the issue but was unable to replicate it. Although the in-flight reset was successful, this failure played a dangerous role in the events of Flight 6. The freighter modification of the Boeing 747 includes 3 cargo holds. One large compartment on the main deck beginning under the cockpit and stretching all the way to the tail, as well as 2 compartments in the lower hold. The upper deck, which is located in the iconic hump at the front of the aircraft, contains a crew bunk and other crew rest facilities. Originating in Hong Kong, a major hub for electronics manufacturers, the 747 was carrying a large shipment of various electronic devices such as laptops and pocket readers, as well as multiple containers with lithium-ion batteries. With the rapid growth of portable electronics, lithium-ion batteries have become extremely widespread around the world as a source of energy. Yet in the early 2010s, the transportation industry was just starting to fully appreciate the dangers and hazards these batteries pose, especially if mishandled. Subjected to extreme temperatures, overcharging, or damage, a lithium-ion battery can be at risk of overheating and catching on fire, a condition called thermal runaway. What's worse, a fire produced by a lithium battery is almost impossible to put out. For that reason, carriage of lithium batteries is highly regulated and is only permitted in cargo aircraft when the shipment is classified as hazardous cargo and accompanied by proper paperwork, which should clearly indicate the quantity and type of batteries transported on the plane. Despite the requirement, the cargo manifest for Flight 6 did not include proper declarations. With the additional containers loaded onto the main deck and the crew ready at 6:51 p.m. local time, UPS Flight 6 took off from runway 30 right at Dubai International Airport. Chasing the setting sun, the aircraft turned northwest bound and began its climb over the Arabian Gulf. The first officer hand flew the initial climb portion of the flight before turning the autopilot on and settling into his seat for the 8-hour leg to Germany. Within 10 minutes after takeoff, as the aircraft was passing 10,000 feet, the Engine Indicating and Crew Alerting System, or ICAS, informed the crew that the air conditioning pack number 1 had failed. The captain successfully reset the faulty pack and, after reviewing the aircraft documentation, determined that the flight could continue to its destination. The situation appeared normal once again, and nothing suggested that things would shortly turn for the worse. Minutes later, the aircraft approached the boundary of the United Arab Emirates Air Traffic Control Area, and ATC in Dubai handed UPS Flight 6 over to Bahrain Flight Information Region, the next airspace along the route of flight. After switching radio frequencies, the crew routinely checked in with Bahrain's air traffic control, only minutes away from reaching their cruise altitude. Suddenly, at 7:12 p.m., a loud alarm broke the serenity of the quiet evening departure. It was the fire bell accompanied by a fire warning master warning light. Captain Lampy read the ACARS message out loud: "Fire. Main deck forward." Triggered by one of the smoke detectors inside the cargo bay, the system was alerting the crew of a potential fire on the main deck. The culprit, a lithium battery thermal runaway inside one of the cargo containers. The container had already been burning for at least 10 minutes before the smoke detectors were activated. An onboard fire can quickly spread and burn down an entire aircraft while producing deadly smoke, and thus it must be dealt with promptly. In response to the alert, the captain took over control of the plane, declaring an emergency with Bahrain's air traffic control and notifying them of the need to land immediately. Reviewing their current position on the radar, ATC informed Flight 6 that Doha, Qatar, was 100 nautical miles to the southwest of the aircraft. However, without appropriate approach charts for Doha and only being slightly further from Dubai, Captain Lampy made a decision to turn back and return to their departure airport. Turning 180 degrees back toward the United Arab Emirates, the crew initiated an emergency descent to 28,000 feet as part of the non-normal checklist. They donned the oxygen masks and activated the aircraft's main deck fire suppression mode. Engaged by the push of a button, this mode shuts off 2 of the 3 air conditioning packs in the aircraft. By leaving only Pack 1 operational, the plane would depressurize the majority of the fuselage while maintaining positive air pressure in the forward section, thus pushing the smoke out from the flight deck. This cargo aircraft was not equipped with an active fire suppression system on the main deck, as is common in many freighters due to design limitations and operational constraints. Instead, it relied on passive oxygen reduction by maintaining an altitude of 25,000 feet to slow or suppress a fire, an approach that can be effective for typical combustible materials but is largely ineffective against lithium battery fires, which generate their own oxygen during thermal runaway. The next step in the non-normal checklist for an in-flight fire was to descend or climb to 25,000 feet, as the reduced concentration of oxygen at this altitude can help smother a fire and prevent its expansion. Despite the checklist instruction, the captain decided to continue the descent to 10,000 feet. Although the emergency checklist procedure was not followed, this step did not impact the outcome of the flight because lithium-ion fires are not oxygen-dependent. Deteriorating the situation further, Pack number 1, the only pack that was still operating, had shut down once again due to the turbine failure inside the unit. Preoccupied with the emergency, the crew did not reset it this time, leaving the aircraft without a working pressurization system. In normal operation, pack number 3 is supposed to restart automatically if pack number 1 shuts off, ensuring normal operation. However, in compliance with the non-normal checklist, one of the pilots had moved the overhead switches for packs 2 and 3 to the off position, preventing the system from restarting them. The loss of aircraft pressurization further caused the equipment cooling system to switch to the closed-loop mode. This system normally sends outside air to the aircraft's avionics for cooling purposes. But without a supply of outside air, it began circulating the air inside the plane, sending toxic smoke into the flight deck. Desperate, the captain asked the first officer to pull the smoke handle. Located in the overhead panel, the handle opens the smoke shutter, a small opening at the top of the flight deck that can release the air inside. Although pulling the handle was not a part of the checklist for this situation, it was an attempt by the crew to get rid of the smoke by all means available. But without a working pressurization system, opening the shutter created a pressure differential that dragged even more smoke into the flight deck, making things only worse. Within minutes of the aircraft's initial turn back to Dubai, as the smoke began traveling through the cargo bay, more smoke detectors became active, alerting the crew of potential fires even further back in the aircraft. At the captain's request, First Officer Bell began setting up the aircraft's navigation system for the approach. Although the smoke was covering the instruments, he was able to input the correct frequency for the instrument landing system of runway 12 left. Once in the range of the radio signal for the ILS, the aircraft would be able to automatically follow the radio beam to the runway. Disconnecting the autopilot to manually control the aircraft's descent, Captain Lampy made another harrowing discovery. Despite pushing the control yoke all the way forward, the plane was barely responding to his inputs. In the same fashion, pulling the yoke all the way back resulted in minimal changes to the aircraft's pitch. It was almost as if the aircraft's yoke became disconnected from the elevator, a true nightmare that became a reality for the crew of Flight 6. As the fire grew and burned through the interior liner of the cargo bay, it was directly affecting the flight control cables. Subjected to the extreme heat, the cables began to lose tension, becoming less effective in manipulating the elevator. As a result, a nearly full deflection of the yoke led to only a small movement of the elevator, and controlling the pitch of the aircraft became close to impossible. Unable to move the flight controls, the captain turned the autopilot on once again. Because it is connected to the elevator directly, the autopilot was not affected, giving the crew at least one way to control the aircraft. This, however, was only one in the series of problems they were facing. Descending through 21,000 feet, Captain Lampy commented to First Officer Bell that the flight deck was becoming too hot. A few moments later, despite still having ample supply of oxygen in the tank, the flow of oxygen in the captain's mask got cut off. The oxygen line connected to his mask had overheated and failed. Unable to properly breathe, the captain left his seat in search of a portable oxygen bottle located in the back of the flight deck. With the blinding smoke complicating the search, he could not find the bottle before passing out. 10 minutes after the first sign of trouble, First Officer Bell suddenly found himself in control of a complex two-pilot aircraft in distress as a single pilot. He could no longer clearly see the flight instruments and judge his airspeed, heading, or altitude, forcing him to rely on position updates from air traffic controllers that too started to fall apart. As the aircraft got to a lower altitude and further away from Bahrain, it flew out of the controllers' range. Despite their best attempts at communicating with the aircraft, ATC in Bahrain were no longer able to reach Flight 6. Switching to the United Arab Emirates area frequency would solve the problem. But much like the rest of his instruments, Bell could not see the radios. To maintain communication with the 747, Air Traffic Control requested assistance from other commercial aircraft to relay the transmissions. A crew from another aircraft in the area would communicate directly with UPS Flight 6 and transmit the message to Bahrain ATC. Controllers in Bahrain called their counterparts in Dubai by a landline to deliver the message. Then came the response, traveling through the same communication chain in reverse order with an average message delivery time of 15 seconds between Flight 6 and ATC. The process was lengthy and inefficient. Yet it became the only communication link. Approximately 50 miles from Dubai, the aircraft passed through 10,000 foot heading for runway 12 left. Flying toward the airport, the first officer continued his attempts to communicate with air traffic control, including on the Universal Emergency Guard frequency, growing understandably frustrated by the inefficiency of communication relays. Although using the guard frequency would provide a direct communication link between Flight 6 and ATC, neither side could hear the transmissions on the frequency as the volume on the receiver was turned down. Minutes later, ATC relayed to Flight 6 the clearance to land on runway 12 left and an instruction to turn slightly right, heading toward the airport. 20 miles from the runway, Bell informed ATC that he was descending further to 4,000 feet in preparation for landing. By now, he was operating almost entirely in the blind, unable to see the flight instruments and using the autopilot to control the aircraft by setting the desired heading and altitude on the mode control panel. Finishing his transmission, Bell pushed the approach button, arming the glide slope and the localizer modes of the autopilot. These modes signal the autopilot to lock onto the radio signal. Once the onboard aircraft systems receive and process the signal, they will automatically guide the aircraft to the runway, following the radio beam. When the aircraft entered the range of the vertical signal for the ILS, the autopilot's glide slope mode switched to captured, ready to initiate the descent. However, the 747 was still not on the final approach course, and without capturing the localizer, the autopilot system could not fly any lower. It is a limitation implemented to prevent an accidental descent into terrain outside of the protected runway environment. Per the instruction from ATC, the first officer set the new heading of 115 degrees on the MCP, commanding the autopilot to turn the aircraft on a desired path for intercepting the localizer. Yet, approaching the runway at over 350 knots, the plane was far too fast for the flight computer to receive and process the signal. As a result, the 747 flew past the final approach course toward the airport's perimeter fence and turned parallel to runway 12 left. Through another relay transmission, the controller informed First Officer Bell that he was 8 miles from the airport, and at 7,000 feet, the aircraft was twice as high as it should have been at this distance from the runway threshold. Hoping to catch the glide path again, the pilot switched the autopilot to vertical speed mode, setting the descent rate to 2,000 feet per minute. Then, a few seconds later, it was further adjusted to 3,700 feet per minute, nearly 4 times the standard approach descent rate. 6 miles from the runway and still traveling at 350 knots, Flight 6 would reach the threshold within a minute, hardly enough time to descend, slow down, and land, even with an extremely aggressive descent. Realizing that the aircraft was too high and too fast, the controller relayed that information to Flight 6 and asked the pilot to make a 360 degrees turn and lose altitude. Negative, negative, negative was the only response from Flight 6. Despite being too high, Bell tried to configure the aircraft for landing by extending the landing gear, moving the flaps to the 30 degrees position, and extending the speed brakes to slow the plane down. Nothing went as expected due to the control cable damage from the fire. The landing gear did not respond to the landing gear handle, and the wing speed brakes moved up only slightly instead of deflecting to an angle of 25 degrees. Detecting that the aircraft was still too fast, the flap over speed protection stopped the wing flaps at the 20 degrees position, while the aircraft's autothrottle reduced engine power to slow down to the flap limit speed of 225 knots. Overflying runway 12 left, First Officer Bell relayed to ATC that he had no landing gear and asked for an update on his position as he would not be able to land in Dubai. The controller offered him to attempt a landing at the nearby Sharjah airport, only 10 miles to the north. If he turned the aircraft to a heading of 095 degree, Bell could try to join the final approach course for runway 30 in Sharjah. He read back the instruction, but accidentally set the heading to 195 degrees, instructing the autopilot to make a hard right turn in the opposite direction. Still unsure of his position, he asked for an update on the altitude, heading, and airspeed.